Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to talk about algebra and problem solving. Basically, we're going to start introducing how to work with word problems. We're going to start giving you the skills today to learn how to read and write word problems to make solving word problems a little bit easier. In order to understand and solve word problems, you must first learn how to translate words into mathematical terms. This is very, very important. You must read word problems and even words that form expressions, okay, not necessarily even equations. You must read them very carefully, and you must learn how to translate words into mathematical terms. First things first, though, remember that an unknown is a variable. Okay, remember that a variable is a letter or a symbol that represents a number or value. And these variables usually are expressed as x. Okay, you can use any letter you want to represent a variable, but x is very popular. So is n. Okay, so is n, but x is very, very popular. Okay, so let's get to it. I'm going to give you a little table here, okay? They're word phrases to math operations. So I'm going to go through individual words or phrases that indicate each operation. And I want you to go ahead and hit pause after I go through all of them so you can have time to write them down, okay? Okay, so addition. Let's talk about words or phrases that mean addition. When you're reading problems, if you see the word sum, that indicates addition. That's pretty much the most popular word used for addition, okay? Is the answer to an addition problem. Plus, greater than, more than, exceeded by, in excess of, added to, increased by, combined, altogether, together, and total of. So all of these words or phrases indicate addition. So go ahead and hit pause now, please, in order for you to make sure that you have all of these words written down neatly and carefully. I want you to really absorb this. So please hit pause now. Thank you. Okay, welcome back. Let's talk about words that indicate subtraction, words that mean subtraction. Number one, difference. Okay, that's the most popular one. You're going to see that a lot in word problems. Difference means subtraction. Difference between. Difference of. Minus. Subtracted from. Subtracted by. Less. Less than. We're going to get back to these two. I want to talk about the difference there. Very important. Decreased by. Fewer. Fewer than. Okay, all of these words indicate subtraction. Now I'm going to pause in a second. However, I want to go over less and less than very carefully because there's a big difference here. If I go ahead and tell you x less 5, that's just simple, straight up subtraction. That's just going to give you x minus 5, okay? So less is just straight up subtraction. You don't have to worry about it. However, less than, okay? Whenever you see the phrase less than, I want you to remember to switch. Switch what? Switch the first term with the last term. So for example, if I tell you x less than 5, well, you have less than. So x less than 5. You're going to switch the first term with the last term. So the last term goes first and the first term goes last. So it would equal 5 minus x. Okay? Please pay attention to that. Please make sure you understand that. X less 5 is just x minus 5. But x less than 5 is 5 minus x. Whenever you see less than, remember to switch. So, okay, my friends, if you would go ahead and please hit pause right now in order for you to make sure you have all of these words and the description of less than written down in your notes clearly, neatly, I would appreciate it. Go ahead and hit pause now, please. Okay, welcome back. Multiplication. Okay, just like addition and subtraction, there are key words that indicate multiplication. So here we go. Let's do it. Multiplication can be represented by any of these words. Of. Of is a big one, okay? Of is huge. 3/5 of 20. He had 2/8 of the pizza. Of is used everywhere, and of is multiply. Times, of course. Multiplied by. Product. Product of. Per. I have a little asterisk there. I'm going to explain why in a little bit. Twice. Double. Triple. Half. Increased by a factor of. Decreased by a factor of. Let me explain some of these. Now, per, first of all, per has a little asterisk because per can be actually multiplication or division. It depends on the way they phrase the word problem. If I tell you that you're paying, for example, $5 per shake, okay, and I want to find out, let's say you spent $50. Okay, that's what you spent. And I want to know how many shakes do you have? Did you buy? Okay. So in this particular case, pretty, simple word problem, but I just want you to understand how the word per can work here. If it's $5 per shake and you spend $50, you want to know how many shakes you purchased. Well, I know everyone knows it's 10, but why? Let's set up an equation. Well, we have $5 per, in this case, times X, okay, where X is the number of shakes, equals $50. Okay, whenever you're setting up a word problem, always label. So I would have said X equals shakes. And then you go ahead and solve from there. But a key here is understanding that per can be used for multiplication. I'm going to show you now in a second how it's used in division as well. Let's talk about these twice, double, triple. Okay, twice, that just means 2 times whatever they're talking about. So it's just 2 times. Doubles, the same thing, 2 times a variable x, 2 times x. Triple, that just means 3 times x. Half, that just means half times x. Increased by a factor of. Let's say they tell you that production was increased by a factor of 4. So that means that the original amount that they produced or they manufactured was increased by a factor of 4. That means it was 4 times greater. So that would be 4x. Let's say that production went down and it decreased by 40% of the original. Well, 40% is 0.4 of the original x, okay? So please go ahead and write these down. Make sure you have everything nice and neat. Make sure you have the examples, please. And go ahead and pause now. Thank you. Okay, welcome back. Division. Okay, there are key words that indicate division as well. Now let's start. We've got quotient, very, very big and popular word. We've got divide. We got divided, divided by, per. Notice I have the asterisk again around per. We'll talk about that one in a second. Ratio of. Okay? All of these words indicate division. Now let's talk about per for division, because per can be multiplication as well. All right, let's go back to the shake thing. Let's say it's $5 per shake. Okay, and I tell you that again, you spent the 50, actually, let's say that we don't know what you spent. Okay, let's say it's $5 per shake. Now, give me 1 second, please. Okay, sorry about that. All right, actually, let's go backwards here. Let's say that you spent $60 on shakes. Okay, and you purchased, let's say, 12 shakes. Okay, and I want to find out how much is it per shake. So how much per shake? In this case, we're talking about division, all right? In this particular case, we have 60 shakes divided by 12 equals X, which is my price for each shake. X equals the price per shake. Okay? So it really depends on the way they word the problem, but per can be used for both multiplication and division. Okay, go ahead and hit pause for me, please. Write all of this down and make sure it's nice and neat in your notebook. Thank you. Okay, let us continue. Equals. All right, equals is very important. A lot of people don't give the value to equals that it deserves. But the word is represents equals. In fact, any tense of that, are, was, were, will be, okay? All of these, gives, yields, all of these words will mean equal, okay? Please remember these. Make sure they're written down neatly in your notebook. Go ahead and hit pause, please, so you have time to write them down. And thank you. Okay, so let's put these words to play now. Let's practice. Write each word phrase as numerical or algebraic expressions, okay? Number one, the sum of 3 times a number and 8. Okay, let's think about it. Let's read. Let's focus. The sum of 3 times a number and 8. Okay, so the sum, which is 3, the sum, so it's of 3 times a number, 3n, and 8. Now, this one's a little bit confusing because it says sum and of. But think about it. It's the sum of 3 times a number and 8. So in this case, even though the word of is used, multiplication is used for 3 times a number, but not for this of in particular. So you got to be real careful. B, the difference of a number and 9. Well, difference of a number and 9 is n minus 9. Again, of was used here, but not in the context of multiplication. the product of 4 and negative 6. Okay, well, we have product. I've got negative 4 times 6. The quotient of a number and 2. So we're talking about quotient of a number and 2. 9 less x. Okay, we're talking about 9 minus x. Remember that less is just straight up subtraction. But when I tell you 9 less than x, remember we're switching the first for the last. So this would be x minus 9. 3 times the sum of a number and 15. Okay, 3 times the sum of a number and 15. So in this case, it's 3 times the sum. So the sum had to be put in parentheses. A number decreased by 35. So it's a number decreased minus 35. Okay? It takes time to become a master of this, so have a little bit of patience. Please don't get frustrated. You're going to have a lot of homework questions to practice. Let's continue. Okay, now let's get a little bit more descriptive, a little bit more challenging. Write each word phrase as numerical or algebraic expression. Okay, the Dolphins scored P points in a football game. The Jets scored 12 more points than the Dolphins. Write an algebraic expression for the number of points the Jets scored. Okay, let's make a little table. This is a very important skill that you should get used to right now. Writing tables is going to make your life easier when solving word problems. So, we've got the Dolphins and we've got the Jets. The Dolphins scored P points in the football game. Okay, so they scored P points. The Jets scored 12 more points than the Dolphins. So the Jets scored the Dolphins points P plus 12. So what's the algebraic expression for the number of points the Jets scored? P plus 12. It's very simple if you make a table. Please don't get lazy and not write the table. This is going to be a very, very important skill for you, like I said, for word problems. A lumberman cuts 50-foot log into 2 pieces. One piece is y feet long. Express the length of the second piece as an algebraic expression in y. Okay, so a lumberman cuts a 50-foot log into 2 pieces. All right, so we know we have 2 pieces. Let's make a little table. We got the first piece and we got the second piece. One piece is y feet long. So the first piece, we're going to call it y. I want you to express the length of the second piece as an algebraic expression in y. Okay, so that means I want to include y in this expression. Well, if the first piece is y, how long would the second piece be? Sometimes it's difficult to visualize this without putting numbers. So let's put numbers into this. You have a 50-foot log and you cut it into 2 pieces. Let's say that the first piece was 10 feet. How long would the second piece be? Hopefully you said 40 feet. If you did, great job. Why now? How did you get 40 feet? Well, you may be thinking, that's easy, Morrow. Go ahead and go 50 minus the 10 that you cut, and that's going to be 40 feet. That should make sense, right? Okay, cool. Now, let's translate it into an expression using y. Didn't we take the 50 feet that we started with and subtracted the piece that we knew that we cut already? Well, we know that the first piece is y feet long. So how much are we taking away from this 50 feet? These y feet long. So my second piece has to be 50 feet minus the y feet that I already cut off in the first piece. So the algebraic expression for the length of the second piece is 50 minus y. Again, I don't want to be a broken record, but these tables are key. They're clutch. They really help you out. The number of quarters in a drink machine is 2 less than the number of dimes D in the machine. Okay, so we're talking about dimes and quarters. And it says that the number of quarters in a drink machine is 2 less than the number of dimes D. So dimes is D and Q is 2 less than. Remember that less than means switch. So it's 2 less than the number of dimes. So since it's 2 less than the number of dimes, it is D minus 2. So the expression for the number of quarters as an algebraic expression in D would be D minus 2. Again, tables, very, very important. Okay, next. Write each word phrase as a numerical or algebraic expression. A cash register contains Q quarters and N nickels. Write an algebraic expression for the amount of money in cents in the cash register. Well, I know that I have Q quarters and N nickels. So most people will just go ahead and say, oh, the number of quarters plus the number of nickels equals the money in cents in the cash register, right? Okay, that would be wrong, unfortunately. Why? Because we're looking for money, okay? First of all, let's label. M equals money in cash register. We know that Q equals quarters, and we know that N equals nickels. But remember that when we're talking about values, we have to put values. So remember that quarters is 25 cents, and nickels are 5 cents. So when we really are looking for this, okay, we've got the number of quarters, 25 cents per quarter. You may be thinking, why don't you write it as 0.25? Because they already established that this is going to be in cents, okay? Plus 5 cents for every nickel, okay? That's going to be the amount of money in the cash register. In this particular case, we didn't really need to say equals M, but I wanted to give you a visual of how it worked. So M, like I said, is not necessary here because they're just looking for an expression, and the expression would be 25 cents for every quarter plus 5 cents for every nickel, hence 25Q plus 5N. Okay, Max is driving to Orlando at a rate of 68 miles per hour. Write an algebraic expression describing how far Max travels after T hours. Okay, give you a little hint here. D equals RT is a very important formula you want to learn. Distance for D equals R, which is rate or your speed, times time, T. Okay? So in this particular case, I want an expression. But in order to write the expression, I'm going to use this equation. We know that the rate, okay, Max's rate is 68 miles per hour. I want to write an expression describing how far Max travels after T hours. Well, distance equals rate times time. And I know that he's traveling at a rate of 68 miles per hour, so my distance would equal 68 T. Okay? That's the equation, but they want just the expression describing how far Max will travel. Well, the expression for distance equals 68T, correct? Distance equals 68T. So my expression here is just 68T. Now you may be saying, what's the difference? Why did you leave out the D? Why did you leave out the M in the example before? Because we're not looking for equations, okay? When we talk about equations, we're going to include the word is or was or were. These are just expressions, and expressions do not have equal signs. Okay, you deposit $800 into a bank account, earning 5% interest compounded annually. The balance A in the account after T years is A equals 800 times 1 plus 0.05 raised to the t power. Using your calculator, guess and check to find how long it will take to double your money. Now, there is a procedure, a mathematical skill that we can use to easily solve this, but we're just not there yet. So since we're just introducing expressions and word problems, I just want you to learn how to sometimes play with numbers to get the answer that you need. And sometimes a very powerful tool is to just guess and check. Now you have your calculator, so go ahead and set up your calculator exactly as this is written here. So you've got 800, open your parentheses, 1 plus 0.05, close your parentheses, and then raise it to now a power that you so choose fit. Okay, so let's raise it to, I don't know, think about it. We got $800, it's 5 years, and I want to know how long it's going to take to double my money. So I'm going to go ahead and say 10. Let's go ahead and put 10 in there. So again, we're replacing this t now as an exponent of 10. That's my first guess. And that's going to equal $1,303.16. It's not quite double. We got to go a little bit higher. So 10 years was there. Okay, let's try it again now, but with, let's say 12 years. Let's go ahead and check on that one. So again, 800 times parentheses, 1 plus 0.05, close the parentheses, raise it now to the 12th power, and we're going to get 1436.69. Yeah, that's not going to work either. Let's go a little higher. Let's go ahead and try 15 years. Okay, so again, we've got 800 parentheses, 1 plus 0.05, close parentheses, raised to the 15th year, and that's going to equal, oh, there you go, 1663.14. Let's see what 14 years is. Let's see if that's any closer. 800 times parentheses 1.05 raised to the 14th year. That's going to be 1583.95. So yeah, 15 years is the closest, in between 14 and 15. Okay, so it's going to take roughly about 14.5 years. Okay, sure, you had to guess and check, but you got to your answer. So sometimes guessing and checking is very useful. The outer dimensions of a rectangular garage are 15 by 20. The washer and dryer area takes up 1/5 of the garage's area. Find the total area of the remaining space in the garage that can be used for parking your car. Okay, so let's check this out. We've got a whole entire problem in this case. So let's solve it. The outer dimensions of a rectangular garage are 15 by 20. So, okay, so I've got a rectangular garage, okay, and it is 15 by 20. And I know that there's a little washer dryer area, so let's go ahead and draw the little washer dryer area. And it is 1/5 of the garage's total area. So it is 1/5 of, that means multiply, the garage's area. Find the total area of the remaining space in the garage. Okay, well, in order to find the area of the wash dryer area, I need to find the whole area. So remember that area is length times width, okay, or base times height. And I've got my area here will equal 15 times 20, which equals 300 square feet. That's for the total area. I want to find now the area of the washer dryer area. So if my A is 300 and my washer dryer area is 1/5 of A, my washer dryer area equals 1/5 of 300, which is 60. So the area of the washer dryer area is 60 square feet. So This is 60 square feet. The whole entire garage is 300 square feet. I want to know the area of the remaining space. Well, that's going to be this part right here. And that will be 300 minus the washer dryer area of 60. And I've got 240 square feet left for the rest of the garage. And that I could use for my car or whatever other things I may need to store. Okay? I hope this helped. Hope you understood, and I hope you learned a lot. Thank you so very much. Have a great day, and I'll talk to you later. Bye-bye.